calibration. Okay, now as I said, we focus more now on the practice side. We talked about the theoretical background of the topic, and now I would like to move a little bit slowly into the practice, the practical aspect of the building information plan. So to do that, let's first look at the traditional way of designing and building, and that's what we are doing now in Sudan and many other parts of the world. So even in the Middle East. So now I'm in Kuwait helping them do the same thing like this by building a curriculum and also introducing BIM into major projects. So in the traditional workflow, which all of us now, if you are in practice, will be doing, you start with the architectural concept, the concept from the owner, and then we transfer it to architectural drawings. And those architectural drawings will be communicated to the different consultants, like structural engineers, chemical engineers, and electrical engineers, and those will start work on their design based on the design received from the architect. So the process is very linear and sequential. One step has to finish before the next, and this has to finish to go to the next. And then after that, then there will be, files sent back and forth, whether it's hard copies with markup or PDF file, with the markups sent back to the architects, and they send back and forth, so move the video. So this will take a lot of time. And it is associated with errors, associated with omissions, right? Almost. So, on the other hand, the BIM approach, or what we call it the BIM-based workflow, is different. It's more dynamic in nature. It's not sequential. It's not linear. So all drawings and all can be derived from a single model. Coherence between the model and drawing is always there, and the model itself will do the coordination instead of manually being done. And there's so many information you can, and it does cover the entire project life, the project life cycle. And also you can achieve a lot of visualization and rendering and so forth. And this is just to give you an idea about the different pieces of the design process and BIM. As you can see, the BIM in the middle here will be shared for all those phases, during the analysis, conceptual design, detailed design. So all of those steps, all of those phases will be communicated in the same model, the same source. So that's very important part of the BIM approach. I'm going to look into this a little bit more deeper. So it is a single source of data. So a single source, single file being shared across the different consultants and contractors. And you'll be able to do improved coordination. That's one of the main goals. Reduce errors, omissions, improve visualization, and sharing with the fabrication and so on. And so this is just a simple example to show you, how the scheduling and other you can easily run those. And in this one here, the one you see, this is shows trying to figure out how many beams, all the framing, structural framing elements. So I'm trying to run here a schedule by counting the number of beams used, in the entire project. And then I can group this by 4, okay? Or I can group them by size. So you have so many ways. And then I think we'll do some of those in the workshop. So in other words, BIM will, drastically increase our ability to analyze the life cycle of the design, and will help me also to study many alternatives very quickly. For instance, if the client say, okay, how if you add shading device in this part, how this will look? No problem. I will save that as alternative 1, alternative 2. I can just add the shading devices there, and then I can show the result, the impact on the energy, on the circulations, and so forth. And so virtually you'll be able to eliminate a lot of the waste and errors, and inefficiency will be minimized, and also will help down the road for the operation and maintenance. So now back. Two key issues, or two main that BIM, or the thing, or the aspect that distinguish BIM from CAD are interoperability and defragmentation. Okay? Those are the two key differences. With the CAD, interoperability is a problem, defragmentation. Do you understand what defragmentation means, right, everyone? Right? Anyone has a problem understanding what it means? Right? Everyone does. Okay, so making it like more collaborative, if you like. So I'm going to explain those in the next slides. So start with the interoperability, what that means. So with the interoperability, I'm referring here to the fact that after you create your building model, you will be able to take the same file or the same model and then exchange that with other software. For instance, if you want to design foundation using different foundation software or different structural analysis, there are various structural analysis like SAF 2000, Tekla, Revit, RISA, or and then robot structural analysis. So there are so many, and then for foundation, for masonry wall, there's other software that you can use, and for energy, the other software. So being able to use the same file, the same data for all those analysis type, this is huge improvement. But otherwise, what you will be doing is to reinvent the wheel. For instance, what I did in the past, so I want to design a structure for a building like this, I have to recreate the whole, structural or the geometry or the plans, and then also location of the columns and the floors. I have to recreate this again in a different software to be able to analyze it. But now with the BIM, you don't have to. Although it's not 100%, 100% possible, but I would say 90 to 80% you will be able to, use the original file without having to fix or re-enter the information again while you're analyzing or designing your structure or designing your mechanical system, for instance. So this has been done through the standardization, and the standard used for this purpose, we call it the IFC. Okay? The IFC is the data format, and it stands for Industry Foundation Classes. Right? So if you search the net later after the course, if you want to put IFC, you will see all the different versions and more information about it. So at least according to the US national standard, we are asking all vendors, all software vendors involved in BIM to be able to comply with the IFC. So the software must be able to produce an IFC file. Okay? So this is one of the requirements of the standardization. That way we make sure if this data being used with other software, or if that company dies, what do we do? It's not there, out of business. So your investment is not done because you can create those IFC files, go use it in a different software. Okay, and this is what I mean. So as you can see here, using the same model with different applications, structural application, electrical, mechanical, plumbing, energy, and so on. And defragmentation means bringing all trade, all disciplines, architects, engineers, civil engineers, structural engineers, mechanical, electrical, all into one location or into one platform. That is the BIM model. As you can see in this example, you see we have the foundation grade beams from the structural engineers, and we have the architectural building where we have the skin of the building, the roof spaces, okay, and so forth. And then you see the mechanical and electrical components being brought together, and here you see also the main goal to bring all other participant or stakeholder. For instance, legal data can be brought in due to spatial GIS, for understand the financial data, payroll, and related aspect of that. Okay. So now for productivity, I would say you can implement BIM in different ways. You can implement BIM as an individual if I have my own company, or one partner. Still, implementing BIM will bring me ahead, will give me more than I spend on the software or the training. So, we'll be able to do coordination, and we'll be managing files, we'll be exporting the analysis. So on the left side, you see the benefit of implementing BIM if you are individual or you're working on your own. And the second one shows how BIM can be can be used or can benefit a company that say, okay, I don't care what's going outside, I'm going to just use BIM for all my projects internally, irrespective of what the other people will do. And this also will benefit them a lot. You see, you can collaborate, make collaboration within the company. So, like 4 architects, they work on the same projects. Some of them will work on the scheme, some will work on the interior design, some of them will work on landscape. All of them share the same model. Still will benefit a lot. And then, of course, what we call it internal, external. If you share that model again across different companies with external companies, doing maybe mechanical, electrical, that will be the optimum, which is the last stage. So this is here just a simple example. This my student did. So I asked some of them to. This is an old one, I think 2006 project. Asked them to create architectural model for a simple office building, steel structure. And I asked group them to focus on the structure, and then we brought them together. And when we brought them together, linked them, everything matched. They were, hey, we're so happy. I keep that achievement. So, okay, some of the benefits here, I think last 2 days ago, I think Mohammed talked about this and showed you some more examples, but I want to touch on maybe one and move a little bit quicker. In this one, it shows you how it will be, to see the benefit of BIM when we do the coordination. So in this example, you see once we link the model together, we saw there is a collision, there is interference between the trusses, the steel truss, and the curtain wall, aluminum curtain wall. So they are colliding. Open. Problem. So that must be resolved. And once resolved, the photo on the right shows this the correction after being constructed and resolved. So there's here also another example about coordination issues using the elevator machine rooms. Also, the 2 models from the architects and engineers are not the same. There are some differences. And then after you see the yellow shows the architect and the blue from architect, and this must be corrected. And there's so many more examples, but I think since the time is running, I'm going to just go back again to highlight the key differences between the 2 workflow, traditional workflow and the BIM workflow. Traditional workflow is very linear, sequential, one after the other, whereas the BIM process is very dynamic, right? All happens at the same time. As you can see, everyone talking to each one from early stage. So early on, we bring everyone to the same table. So they will be talking and sharing the information as early as the project or the project inception. Okay, and maybe here this slide just stated that one of the differences between the two. In the traditional, we spend a lot of time in the coordination at the last stage, just before we build. Whereas in the BIM, we spend a little bit more time at the beginning to set the coordination, the collaboration between the difference. That's only we start very early, and the traditional starts very late. So here, just quick, I think last time I talked about this, but here I'm going to give you some ideas about the adoption level in the North America. And this data from the McGraw-Hill Construction report, 2012. As you can see, 2007, even in the US, even by 2007, very few. I started teaching this for 2004, talked to so many companies, still they are not convinced. I've been involved also in the American Civil Engineers Structural Engineering Institute. I'm also a member of, and also co-chair of the BIM in education. And still, we had so much difficult time to convince people. So that's why here it's not a big problem. So if we start today, we're still in good shape. So only 27%, 2009, 49% adoption, and now it's 71%. And I'm pretty sure 2014 it's going to be closer to 90. So by recently, next a couple of months, then the new report will be produced. Okay, I have a few times, but I want to just quickly show you some of the benefits to the owners being recorded. And as you can see here, reduce errors and revisions 61 in 2012. 61% reduction. Okay, whereas 42%. And there's also other, improvement in other areas to owners. So this example, I'm going to just cover one example. I have other more, but I think my time is running out. So this example, being from the literature, this is a recent publication. And they studied, those two guys, they studied about 400 projects over 6 years. Okay? They collected information about those projects being done in BIM and other projects not being in BIM, and tried to come up with some comparison and see the advantages. So this here, the physical conflict by showing the avoiding interferences, they were able to save 0.75. Schedule conflicts were able to save $1.2 million. Data conflict 0.5. And change of order is a big issue. So they were able to, if you compare the 2D projects, they were being done, they were 18.4% change of order. In using BIM, only 2.8. And the goal is to make it 0. Okay? So it's a lot, and this means in big project means huge money. So this again tells the same thing in different ways, going from 18 to 2.6. And also through mechanical plumbing, they will be able to do a lot of, and this example shows 0 conflict. So using BIM, eliminated all the conflict on the construction side. All right, so I think I'm going to skip 4. I'm going to skip, okay, yes, I need this before I make my, I'm going to take a few minutes. So return on investment. So this is the conclusion of the data. So you can see many projects. On this column here, you'll see this how much BIM is going to cost in terms of the software, training, and so on. And here, the direct saving. So what the implementation of BIM brought to me as a result. So how much saving? So this in dollars. That's why it's showing in practice. So it means it's a saving. And if you're looking into return on investment, ROI, okay, on each dollar you spend or invested, how much money back I got. So as you can see the numbers here, sorry, go back. So you can see the numbers in this column. If you go down, the 2007 is huge. So in terms of finance, it doesn't make all sense, right? Even this like how many percent the last one is 300 or 330,000%. It's not 200%, 300%, 300,000%. So you spent like $1,000 and you made 330. That's better than any business in the world, right? Can't compare it with any other businesses, All right, so in summary, I would say BIM data models serve as a principal means for communication between different AAC. AAC stands for architecture, engineering, and construction. And represent the hub of software applications that streamline the delivery process, design, detailing, manufacturing, and construction. And BIM gives architects and engineers an integrated environment. That's very important. Integrated environment. That's what we are going to. That's this is the future. Integrated practice. So in other words, integrated environment for design and application. That's what we refer to as integrated practice. It's very important to keep that in mind. Integrated practice. So moving forward, so maybe the slide here, I'll go back to that. It shows, all the drawing documentation are always coordinated, consistent, and coherent and complete, all the time. And so here are other of the benefits. You can do collision, you can do code checking. I think one of you asked me about the code. So code checking is a huge research area nowadays, whereas you can automate to check the code, energy code, structural code. All of this will be done automatically with the model and give you the result. Okay, this is it's safe, it's not safe, it's okay, it's passed, not failed, and so on. And energy efficiency, sustainability, and so on. And collaborative mode, as the collaborative mode, the integrated practice will become the standard approach in the very near future. So in conclusion, 2 things I would like to conclude with. BIM is not only a digital tool, but also a process, an approach, and a workflow, okay, for construction. And BIM is fundamentally changing, the role of computation in building design by creating a database of the project to be used for all aspects of building design, from architectural design to construction and beyond. Thank you. Thank you again for giving me
نحاول بقدر الامكان ان شاء الله نتكلم بالعربي، نكون محتاج مساعده الجمهور والحضور لترجمه بعض المصطلحات. انا عندي 2 presentations جاهزين، لكن واحده فيهم اتعملت قبل كده يوم الاحد. منو اللي حضر يوم الاحد؟ عدد بسيط جدا، فبيبقى انا حعيد يوم الاحد، اوكي؟ لانها فيها ابجديات كيف احنا كشركه بتاعت مقاولات، انا مقاول كشركه بتاعت مقاولات، ويمكن نعكس لكم يعني دكتور نواري مشكور عكس الناحيه العلميه للبيم وما هو البيم، يعني ادى انطباع عن التاريخ بتاع البيم. ف هي شويه كانت طويله، انا هحاول اختصر، فاعذروني يعني انا هحاول اختصر كميه من السلايدز، يعني همشيها سريع، لكن في نفس الوقت تو هايلايت فائده البيم بالنسبه لنا نحن شنو كمقاولين. وفي نفس الوقت انا افتكر الحضور حقه يعني الهدف يكون انه يخليك انت تطبيقه الليله في السودان يكون يعني ما عمل، نكون واضحين، لكن المطلوب شنو؟ انه الواحد يكون مواكب، الواحد يكون عارف حوالينه حاصل شنو، وثلاثه يفتح آفاقه للممكن شنو. اوكي؟ انا حاسس انا جينا البوديومز دي والكلام هنا حاجه في النص هنا احسن، مش كده هاي ما في مشكله. الصوت كده مسموع؟
مسموع.
اوكي كويس جدا. اوكي انا معاويه السعيد عبد الكريم، اتخرجت من المعمار سنه 88، وسعيد جدا جدا واحيي الشباب النشيط في الرابطه بتاعتنا لكل الادوار اللي بيقوموا بها. أنا شغال في شركة في استخدام البيم شنو، وكيف كشركة بتاعت مقاولات إحنا يعني بنستخدم البيم وفلسفتنا حتى في إدارة المشاريع، وكيف بنتعامل مع الزبون بتاعنا، أو حتى طريقة الأداء والدليفري بتاع البروجكتس بتاعتنا شكلها كيف. أوكي؟ طيب الليلة يعني البرزنتيشن دي حتكون شوية يعني بتحلق فوق، ما حتكون في تفاصيل كثيرة، يعني ما حنخش في كمية من التفاصيل وكمية بتعامل كيف. حنكون محلقين يمكن على 10,000 قدم مثلا، ما يمكن 30، لكن في النص. دي مهمة. As a company يعني أنا حكون جزء بالإنجليزي وبعدين جزء بالعربي وأنتوا ساعدوني في الترجمة. Okay? نحن as a company, our philosophy to exist in the world is to build great things. Even though we're a construction company, but we say great things, not great buildings. Because great things meaning great relationships, like مع الأستاذ دايم هنا. We build great relationships, we build great buildings, we build great teams. Whatever we do has to produce a great product. Okay? Our core values, integrity, enjoyment, uniqueness, and ever forward يمكن حتلمسوا جزء من الكلام ده في أثناء البرزنتيشن. لكن حقيقة we are an ever forward company looking always forward to do things differently. We don't accept the status quo. We are a flat organization. أمس في الجامعة الكلام ده شوية كان في أسئلة فيه. We are a flat organization. We do not have a hierarchy. We do not have a pyramid. We don't have a CEO. We don't have a VPs. Nobody has a title. So everybody is equal. This is the leadership that leads our company. There's 7. And then we've got, I'm going to skip some of it. We have 18 offices from California all the way to Florida. I am in Arizona. About 1,500 employees, full-time staff, and then 1,400 craft people in the field. يعني عندنا 1400 عامل بنشتغل concrete, drywall, door frames, and hardware. We're a very specialized general contractor. We do not do housing, we don't do hospitality, we only specialize in advanced technology, microelectronics, data centers, mission-critical facilities, corporate office buildings, higher education, healthcare. That's my specialty. That's why today, maybe on the case studies, you will see a lot of healthcare projects. Life sciences, زي مصانع الأدوية. I just brought some examples from, I live in Phoenix, but I serve all of our offices. So I brought some projects from Phoenix. This is an eBay data center. I think everybody knows eBay. Right? So every time you go to eBay, the computers that run eBay are in this facility. This is our DPR office building in Phoenix. It's a net zero office building. Everything is controlled by the BMS of the building. It's a platinum, LEED platinum. It used to be the largest office building, net zero office building in the world, but then somebody else, we built it actually for them. This is the College of Nursing, and a hospital as an example. This is a biopharmaceutical research facility. So the kind of projects we build are complex. We have to come up with better ways of delivering projects. So that's our mission. We want to be one of the most admired companies by the year 2030. This used to be very far. We were founded back in 1990, so we're a young company relatively compared to large US companies. Our volume, 1990 we did 0. Last year, 2014, we did 2.5